below the prescribed temperature, then the combustion will not be happening. Okay. Now you will see that this thing combustion. You can see now the process of cooling system in an automobile engine. The significance of the cooling system. As you know, in spark ignition engine, coolant must be satisfied to avoid pre-ignition and knock. What is knocking? It is a tremendous pressure rise. I already explained in the IC engine's portions. If the pressure is raised beyond certain limits, engine will be gets vibrated, which is called as engine knock. During this engine knock, vibration, if it happens for several times, then engine components will be get spoiled. Okay. In case of the CI engine, the diesel engine, since a normal combustion is added, cooling must be sufficient to allow the parts to operate properly. Suppose if the heat is increased beyond certain limits, the parts will be get disturbed. Sometimes it may be spoiled also. In short, cooling is a matter of equalization of internal temperature to prevent local overheating as well as to remove sufficient heat energy to maintain a practical overall working temperature. Means, as I already explained, temperature must be maintained properly, then only it is possible to have a proper combustion. This is the significance of the cooling. Okay. Now, what are the reasons for cooling? Why you want to have this cooling in case of your IC engines is concerned? First one is to promote a high volumetric efficiency. What is volumetric efficiency? It is the breathing capacity of an engine. Normally, higher the volumetric efficiency, better will be the power output. This also I explained in during the working of the engines. So if you have high heat or low heat, the incoming air fuel mixture, which is called a charge, will be restricted. Volumetric efficiency will be kept reduced. So for these reasons, to increase the volumetric efficiency, the cooling must be provided in a proper manner. Then second point is to ensure proper combustion. To have proper combustions, what is our goal? To have the complete burning of the air fuel mixture which is supplied into the engine cylinder. Suppose if it is not supplied heated properly, some fresh air fuel mixture will be gone out through these exhaust processes and contaminating the atmosphere. Not only that, our engine efficiency and the power output of an engine is reducing. To ensure this proper combustion, we have to maintain the temperature of the engine at a prescribed level. To ensure mechanical operation and reliability. What is this mechanical operation? Most of the parts which are maybe reciprocating or rotating, they will come in contact with each other. Because of the friction environment between these parts meeting surfaces and also due to the combustion processes, heat is increasing. If you want to increase the life of the components of an engine, you have to cool the engine in a proper manner. Suppose, one more point, if you overheat, what happens? Suppose if you are over cooling also problem, overheating is also problem. So if you over cooling, if it is happened, say for example, early in the morning or maybe in the winter season, it is not necessary to have the cooling effect. Otherwise, the combustion will not take place. So the thermal efficiency is decreased. What is the thermal efficiency? You already know. This is the efficiency which indicates how best the engine is working. So it is due to more loss of heat carried by the coolant. So since these coolants, maybe water or maybe lubricating oil, who are circulating once the engine starts, suppose in during starting process or maybe in winter season, if you have to overcools, the thermal efficiency, that is heating value, will be reducing. Okay, the vaporization of the fuel is less, resulting in lower combustion efficiency. Vaporization means if the temperature of the fuel is get reduced overall, that is engine temperature, the vaporization of the fuel. So in case of the diesel engine especially, when you are sucking only air in the suction stroke, when the fuel is injected through an injector, suppose if the temperature in that region, if it is lower than the prescribed, the droplet size will be increasing. If this droplet size of the fuel, they are more in size, then mixing problem will be arises. So this leads to the delay period will be increasing, combustion time will be get reduced. Because of this, combustion efficiency is going to be reduced. Now, third point is low temperature increases the viscosity of lubricant, causing more loss due to friction. So suppose the temperature, low temperature, the viscosity, it will become high viscous, then the lubricating oil will not be moving properly to the surfaces where actually it will be circulated. And because of this, more loss due to the friction is increasing. Because of this friction, the components will be gets disturbed or maybe that spoiling the things will be takes place. Now talking about the cooling, what we discussed, cooling is the phenomena in which it will take place maybe in any type of the engines, it is required. So there are two types of the cooling system. First one is air cooling, or also it is called as a direct cooling system. Second one is liquid cooling, or it's also called as indirect cooling. So what is that, or say for example, in one of the sentence which is given here, remark you can see here, aviation engines means that is aeroplanes, helicopters, etc. Motorcycle engines and scooter engines are air-cooled engines. Why this is required in the aviation engines? As we know, weight of the engine, if it is increased by the liquid cooling, then problem will be arises. In motorcycle also the space is very less, even scooter engines also it is less, and weight if it is increasing and the space is increasing, it will not be feasible to have better efficiency. While the stationary and automobile engines are liquid cooled engines, like our motor cars, trucks, lorries, etc., and other automobile engines are of the liquid cooled engines. Okay, now what is air cooling system? Air cooled engines depend on airflow across their external surface of the engine cylinders to remove the necessary heat. The amount of heat dissipated depends upon. See here, once already discussed in case of the IC engines, classification of the IC engines. Engines are classified based on the cooling, air cooling system and water cooling system. So in air cooling systems, we are exposing the incoming air to the engine top head so that the fresh air will absorb the heat from the engine surface and it makes the engine to be cooled. So what are the points required for this air cooling system? The first one is the area of cooling surface in contact with the air. Means how much area is will be in contact with the air, that much heat can be dissipated to the atmosphere so that engine can be get cooled. So it also depends upon the mass flow rate of the air. How much mass, how much quantity of the air will become in contact with the contact surface, and it will be removing the heat from that surfaces. Then other point is temperature difference between cylinder and the air. We already know the temperature of the cylinder. Since the engines are working with a high temperature, and the temperature of the atmosphere or the air in which they come in contact with will be less. So now heat will be transferring. You are already studying in heat transfer. Heat will be, or temperature, that is heat will be transferred from higher altitude towards the lower altitude. Since cylinder temperature is high, air temperature is less, and depending upon this difference, that much quantity of the heat will be dissipated to the atmospheric air. Then conductivity of the metal, that the thermal conductivity of the metal, what quantity material you are going to be used there. So depending upon the thermal conductivity of the metal, the amount of the heat transfer which will be takes place. So all these 3-4 points are very important in air cooling system. And in this case, the first, the area of cooling surface, how you are increasing the area of the contact surfaces. So you can see here, cooling fins are in air-cooled systems. As you know, the fins, already you studied the fin chapter in heat transfer. The contact surface area, if it is increases, see the point number 1, the area of cooling surface in contact with the air. If suppose if you see these are the fins, suppose if the fins are not there, you can see here, if the fins are not there, only the surface area is limited here. So the contact surface area is limited. Because of that, the heat dissipation rate will be reducing. So instead of that, we are increasing the contact surface of an engine by providing these fins. Fins may be in a rectangular shape or maybe triangular shape or maybe like the circular shape, etc. You can see here, this is the cylinder and this is the cylinder head. Around the cylinder and the cylinder head, we are pasting or we are providing the fins. And this number of fins, their sizes depends upon the design criteria of a whole engine is concerned. So now you can see here the area of cooling surface is increased by forming the fins. You can form by integrally or by machining. In some of the engines, either they integrally manufactured or they may be machined after manufacturing cylinder and cylinder head by attaching separate fins. Some engines we are attaching the fins over here. So air cooling system advantages. What are the advantages? The absence of radiator, cooling jackets, coolant and pumps make the engine lighter. Some of the components which are used in water cooling system, which will be not there. Radiator will not be there. Hello? Pardon? Hello? Are you hearing me? Hello? Dear students, it is audible? Hello?
Yes, sir.
Yeah. Clear, no? Like this explanation is enough? Hello? Can you hearing me, please?
Yes, sir. Yes, sir.
Yeah. Now, air cooling system, what are the advantages? The absence of radiator. Some of the components which are used in water cooling systems, it will be not there. Like radiator, your cooling jackets, coolant, and the pumps. The pumps which are to pumping your water, which will be absent there. Okay. Because of that, engine will be lighter. Hello. Those are the sounds you can be reduced, please. The engine can be operated in cold climate where liquid may freeze. Say in some climatic conditions like Kashmir valleys and some other parts, during this winter season, the cooling water may get freeze there. If suppose in water cooling system, if used in such type of the climatic condition, this liquid may freeze and it will not be circulate around the hot spots of an engine, so cooling may not be takes place. Because of that reason, we are using air cooling system. Okay, in places where water is scarce, air cooled engine is an advantage. Suppose in some parts of a country like Rajasthan and other parts of the country, or maybe in other countries, etc., water scarcity will be there. It is not possible to use water for our cooling system is concerned. In that case, this air cooling system is an advantage. Then handling of liquid coolant requires piping and pumping auxiliaries. Again, increasing the components by this coolant piping or pumping auxiliaries like pumps, etc., valves, etc., thermostat valve, etc. This leads to increase in the cost of the cooling system as well as the handling, maintenance cost and maintaining of this such components will become difficult. But in this case, in air-cooled system, it will be not there. Air-cooled engines have no coolant leakage or freezing problems. In water-cooled or liquid-cooled system, any leakage occurs during the flow of lines like pipings or pumps, etc. And freezing problems which will not be there in case of the air-cooled engines. So these are some of the advantages of the air cooling system. Where there are advantages, there will be always disadvantages as well. So relatively large amount of power is used to drive the cooling fan. Suppose if you want to have a proper cooling, it requires the fan to rotate, and this fan is required power, and this power is used by
Rahul.
engine only. So relatively large amount of power is used to drive the cooling fan, so that when the fan is rotating, it is supplying air to the cylinder head and heat will be dissipated through this process. Engines use low power output, means proper cooling phenomena which will be not taking place in engine because only the contact surface, example cylinder head and cylinder some part will be exposed to the atmospheric air, and because of that only that portion heat will be dissipated. Other, especially in case of the multi-cylinder engines, this air cooling system is not at all feasible because cylinders are arranged one by other, one to other each other. The gap in between, they are attached to that. So heat will be generated. It will be difficult to dissipate heat in that region. Because of that, air cooling system is not at all feasible. Cooling fins under certain conditions may vibrate and amplify the noise level. Suppose if the fins are externally fixed to the cylinder head and the cylinder surfaces, sometimes because automobile engines are not working only stationary, even they are working with the automobiles also. When they are moving after a certain time duration, the engine noise will be, that is the fins may be loosened in that particular position. They get loosened and get vibrated, noise level will be increased. Cooling is not uniform except in case of a single cylinder engine. In multi-cylinder engine, cooling is not uniform because, as I already told, cylinders are arranged one by other in line or maybe V shape, whatever way. So their the contact surfaces get reduced. Suppose if you use this air cooling mechanism, only certain part of the engine will be get affected by this cooling and remaining part will not be getting affected. Because of that reason, your cooling is not uniform. Engines are subjected to high working temperature. In especially in case of the multi-cylinder engines are concerned, suppose if air cooling mechanism is used, the high working temperature, that is temperature is increasing. After some time, that the engine may get spoiled. The parts of not engine, whole engine components may be get affected by with a high temperature is concerned. Okay, so this is about the air cooling system. Air cooling system is a simple one. No extra power is required except fan to rotate, and this power will be taken care by the engine itself, and the components will be reduced. Because of that, engine will become lighter. And but the problem is the even cooling will not be take place in multi-cylinder engines are concerned. Again, coming to liquid cooling system, especially in case of the multi-cylinder engines where number of cylinders are more, 2, 3, 4, 16, etc. In that case, to have a better cooling, we should go for liquid cooling systems. Again, in small engines or very less numbered cylinder engines, we'll have different types of the systems. There are four categories. One is direct or non-return system. Second one is thermosiphon system. Third one is forced circulation cooling system. Then evaporative cooling system. So in engine design, as you know, many engines may be small, maybe big, maybe low speed, maybe high speed. Depending upon the design criteria, we are or you are using different types of thick water cooling system. Compared to air cooling system, here the components are increasing. Components in the sense we must have the radiator, we must have the that is a pump, and we must have the thermostat valve and the flow lines, etc. And separate power is required to operate the pump which is used here. So in this category type of the cooling, the weight of the engine is increasing, the components are increasing, design is little bit complicated compared to the air cooled engines, but will have better cooling phenomenon. Now the first one is direct or non-return systems. You can see here, this is the combustion of the air fuel charge, okay, and we have here the liquid which is placed between the cylinder liner and other part of the cylinder block. So in between, that is liquid will be stored here. So after the combustion, because of the radiation, some percent of the heat will be going to the atmosphere. Some with the contact surface conduction, already you know, conduction, convection, etc. The conduction will happening through the one face of the metal to the other face. In between, it will be flowing here, and remaining the heat from here, it will be moving to the liquid by the convection phenomenon. And because of this reason, the heat released from the combustion of the air fuel mixture is transferred in all directions to the walls of the combustion chamber, either by radiation or by the conduction or by the convection. That's why direct cooling will be taking place. That's why it is called as direct or non-return system. Non-return system means the the temperature will not coming backward like this, because the temperature of the engine is more than the atmosphere. Always the heat will be moving from higher altitude towards the lower altitude. Okay. So cylinders and pistons by direct radiation, by convection currents of the gas rubbing against the stationary gas film which is provided between the two piston and the cylinder, and then by conduction through this stagnant boundary layer of gas and an oil film to the metal wall which will be flowing in this case. So this is called as direct or non-return system. Now coming to the second category, that is thermosiphon system. The main components of this system is, as you know, this is the piston and this is the cylinder. Okay, so these are the hoses or the pipelines. This is a radiator and this is the cooling fan which is coupled to the power of an engine itself. Okay, in this system what happens, a fan is rotated by the crankshaft and draws cold air from the outside. Okay, the radiator is connected to the block, okay, by means of two pipes. One pipe is here and other pipe is here. So when engine starts, what happens? The water from the radiator at the bottom side usually flowing to the hot spots of an engine and absorb the heat. By the absorption of the heat, the water will become light, and because of this lightness, water will be moving in this direction, and it is moving above these things, and it goes to the radiator. In the radiator there are so many flow lines will be provided. They are moving, the water will be moving on the flow lines. Meanwhile the fan will be rotating. It supplies the fresh air here so that water will gets cooled, and the weight of the water is increased, and again it is coming to the in the direction. That's why it is called as thermosiphon system. Here we are not having any pump or any blower or any compressor to circulate the water. Automatically the thermosiphon phenomenon, water will be moving. That is higher, that is heavyweight water will be at the bottom of portions. It flows here, absorb the heat. It will be directly come in contact, indirectly come in contact with the hot spots of an engine, become lighter, and when it becomes lighter, it is moving up, and it is further movement of this one, and it will be goes to the your radiator. In the radiator, water flow lines should be there and moving, and the fan will be providing sufficient air to cool the water. Like this thermosiphon system is working. You can see here the hot water passes through some thin pipelines built in the radiator. Again here, radiator, where it gets cooled. Thus the fluid circulates through the system in the form of convective currents. Already discussed conduction, convection and radiation here. So since in the pipe the water will be flowing and it will be come in contact with the air which is passed from here, and because of this convective phenomenon, water will be gets cooled, and further it will be circulated to the hot spots of an engine. Okay, coming to the next, forced circulation cooling system. So this thermosiphon system is not much familiar in case of the multi-cylinder engines or high-speed engines. Since we know in multi-cylinder engines where the power requirement is required more, or in high-speed engines, because of that high speeds, the combustion is taking place very quick positions within milliseconds, etc. Because of the heat involvement is increasing. Suppose if you go by using either maybe air cooled system or by the thermosiphon system, we are not able to remove the air from the contact surface of the or the hot spots of the engine. What are the hot spots of the engine? Near to the top, that is a top dead center, and about the cylinder head where the exhaust wall is provided, more heat will be generated. Frequently we have to remove the prescribed heat to maintain the constant temperature throughout the working of an engine. If you want to have the engine to be working properly, the heat to be removed frequently. Say for example, in case of the multi-cylinder engines and high-speed engines like 4000 RPM, 5000 RPM, where the power output or the combustion will be happening very quickly. So the amount of the heat generation by the combustion of the air fuel mixture within the cylinder is increasing. And because of this high speed, because of the combustion happening in very short duration of the time, heat generation is also taking place very quickly. Suppose if we use that thermosiphon system, we are not able to remove the heat from that particular type of the engines, and we are going other type of the cooling system, which is called as force circulating or circulation cooling system. You can see here, this is the schematic line diagram showing you the components of the engine. The first one is engine. It is the hotspot of an engine where combustion is taking place. In this case, that is fuel and air is burnt. Because of that, heat will be generating. And this is the thermostat valve, which is provided in between the engine flow line and to the radiator. This is the radiator. This is the fan, which is connected to the crankshaft. And this is the pump to suck in the water from the radiator and to supply over here. Now the water or coolant is circulated through the jackets. Now what we are making here in the water cooling system or pump force circulation system. On the engine surfaces, outer surfaces of the engine cylinder block, the water jackets or flow lines will be formed over here. Okay, so we are knowing how much diameter, how many length, etc. And around the engine head as well, the water jackets are formed. When the pump will be pumping the water, the pump will be flowing through these water jackets or the flow lines, observing the heat from the engine cylinder, and it will becoming hot, and it is flowing towards the thermostat valve, and this thermostat valve allowing the water to flow to the radiator. In the radiator, there are so many flow line like vertically and horizontally placed. Water will be flowing like this. Meanwhile, the fan will be moving or rotating. It supplies the air so that water will be gets cooled, and again further it will be going to the pump. Means pump will be sucks the water from the radiator and it is further supplies. Now, what is the function of the thermostat valve? As we know, this is a specific valve which is provided here at the topmost position from the engine to the radiator in between. Suppose if the engine you are going to be start, so when you are going to start, the engine temperature itself is at atmospheric temperature. Suppose in the cold condition as well, the temperature of the engine is very, very less because of the atmospheric temperature itself. So suppose to happen combustion properly, minimum 70 to 75 degree temperature is required to initiate the combustion initially. Suppose in that condition, assume that temperature is 10 degrees centigrade or 20 degrees centigrade. In that case, suppose if assume that there will be no valve. Since the engines, when it starts, pump will be supplies the water to the flow lines. Directly the water will be going to the radiator. So here what happening? That is combustion is not initiated or it is not happening because the temperature required for combustion is required minimum it should be 70 to 75 degrees centigrade. So now this thermostat valve will be doing that job. So in this case, when we early morning or when you are starting at the time, the pump will be circulating water because it directly connected to the crankshaft. When the water is coming over here, this thermostat valve will not open until the temperature of the engine will be reaches to minimum, that is prescribed temperature 75 degree, 80 degree, 85 degree. It is depends upon the design criteria. Once it reaches the prescribed temperature, the thermostat valve will be opens and it will be allowing the water to flow. Before that, the water from this thermostat valve will be from the other flow line. It is coming over here and again it is further. Once it is temperature is reached, this valve opening will be made like this and water is flowing in this direction to the radiator and it gets cooled here and like this it will be moving. Understood this one? The thermostat valve. It is a bellow type or a dipole type of the thermostat which are used there. You will see here. So pump circulatory system you can see here again it is the same case. So the radiator positions, the fan is connected over here. The flow lines are the water jackets. Here it is a pump, and here we have the thermostat valve over here. So when the engine starts, water will be moving in this direction to all the flow lines or the water jackets here, observing the heat, and it is moving. Suppose the temperature is below the prescribed, from the thermostat valve, water will be coming over here, and again it is recirculated here. Once it is reached the prescribed temperature, then the water will be moving in this direction, and in the flow lines of the radiator, see, you can see the air from this side and from this side through this fan will be applying on this one. Heat will be dissipated to the atmosphere, and water will be gets cooled, and heavy water will be coming to the direction here. That's why it is called as pump cooling or forced cooling system. In the evaporating systems, you can see here, in the system, this will be cooled because of the evaporation of the water in the cylinder jacket in the steam. So in here, the cylinder block, and it is made to flow over here. Now afterwards, after heating, water will become steam, and this steam, the advantage of this from the high latent heat of evaporation of water, by allowing it to evaporate in the water jackets, used for cooling of many types of the industrial engines. This type of the system which will be not used in normal automobile engines. Hello, dear students, following, understanding? Hello, it is audible. I will share. I already shared these videos. You can refer. Any queries you ask me later on. Okay, I already shared these videos to you earlier in the WhatsApp group. Hello. Once again, I will take the classes in a regular time in the college itself. But meanwhile, how much possible in our side we are taking the classes, follow the notes and the slides. If any queries there, ask me either through message or directly contact me through your phone. Okay?
Yes, sir.
Are you understanding? Who is talking?
Yes, sir. But voice is not clear, sir.
Why is my voice? But the problem with network, my network is no problem. But your voice, I will share this video to you later on. Okay?
Yes,
Whatever lecture is taken,
okay,
this is recorded. Afterwards, I will share to you. You can refer it, and these slides are already shared.
Yes, sir.
Yeah. Okay. What is your good name?
Allah Baksha.
Allah Baksha. Are you following? No, Allah Baksha.
Yes, sir.
Slides are visible.
Visible, sir.
My face.
Face is visible.
Okay. So now parts of the things which is the radiator is first one. Radiator parts will be, it is required there, components, and this is what I told, thermostat valve. This thermostat maybe wax we used when the temperature reached about 70 to 75 degree. The wax will be gets cooled, heated up. It become very high viscous. Then the valve will be open and it is allowing water to flow. Okay, cooling fan is another part which is required to make the water to be cooled. Then cooling fan examples, it is fixed like this in the engine. Okay, liquid cooling system advantages: better cooling, makes it possible to reduce the cylinder head and valve seats temperatures. As you know, water will be flowing all around that is flow lines. Okay, so that's why better cooling will be take place. Volumetric efficiency of water cooled engine is higher. If water volumetric efficiency is increasing, power output of an engine is also increasing. Compared to design of engines with apparently smaller frontal area is possible, because if fins are provided, the surface area is increased there. But if the jackets of the flow lines made inside only, so engine can be more. In case of water cooled engines, insulation is not necessary at the front of the mobile vehicle. See, in case of the air-cooled engines to be placed in front of the vehicle, so that the incoming air from when vehicle is moving, the incoming air must apply on the surface of the engine part, then it becomes cool. But here it is not necessary to install engine at the frontal side. Okay, like in aircraft engines, etc., they placed wherever the convenient it should be there. Disadvantages: more maintenance, engine performance because sensitive to climatic condition, because the cooling system will be dependent upon the climatic conditions. Maybe sometimes temperature may be 0 degrees centigrade, sometimes it may be 50 degrees centigrade. Depending on the variation in the temperature, performance will be very, very sensitive. The power absorbed by the pump is again considerable, and power output of an engine is reducing because we are taking power to operate the pump from the engine power itself. That's why power output of an engine will be gets reduced. In the event of failure of the cooling system, serious damage may be caused because we are not knowing. Suppose if any coolant or the water will be leaked in between, the cooling system will be gets affected, overheating of the engine, then we can call it as engine seizing. This problem will be arises in the case of the disease. Okay, understanding? Hello. Hmm. Hello. Hello, it is audible, Alabaksha?